Get out your notes and listen. Shippy's back with a brand new lesson. Laterals on the coordinate plane. Squares and rhombi, I'm going insane. Will it ever stop? Yes, after the test. But we'll review it again when we finish the rest. Alright guys, so today we're going to be talking about quadrilaterals on the coordinate plane, specifically classifying them. Okay, so the objective is to be able to apply properties of quadrilaterals to coordinate points in order to classify the quadrilateral. Alright, a lot right there. Let's break it down real quick, make sure we understand the objective. So we want to be able to apply the properties of quadrilaterals. Right? Properties of quadrilaterals are things that we've talked about, like the length of their sides being congruent, opposite angles being congruent, diagonals being perpendicular, congruent, those types of things that are unique to the different types of quadrilaterals. Okay, so we're going to apply those types of things to coordinate points. All right, well, what are coordinate points? Remember, those are like an XY point that you have on a graph on a coordinate plane. So we're going to be using those properties with points on the coordinate plane in order to classify the quadrilateral. Okay, classifying the quadrilateral just means determining which one of the types of quadrilateral we've learned about, that the points give us. So we're going to take those properties that we know, apply them to points on the coordinate plane in order to figure out what kind of quadrilateral we have. Okay, so first we're going to discuss some quadrilaterals in the real world now that we've talked about all the different types of quadrilaterals. And then we'll talk about some previous knowledge that we've learned in the past that you're going to need in order to do the objective today. And then we'll also discuss various strategies that you can use to classify the quadrilaterals. So there's going to be some different ways to do these problems, but I'm going to give you all of them, and I want to be sure to highlight the quickest, probably simplest way to do them, because that's probably what most of you guys will want to do. All right, and then I'll do some example problems for you. And then last, of course, like always, I'll allow you guys to practice some on your own. So here's some quadrilaterals in the actual real world. So you can see right here, these are kites. I'm sure you guys are all pretty familiar with those. A kite that you could fly, it's in the shape of the quadrilateral of a kite. Then you got this table that is a trapezoid. Okay, then in this flag right here, it's the flag for Israel. You can see this shape right here is a rhombus. Okay, and then down here on the bottom left, you've got what's called a Frida cube. Frida was a Hispanic artist, and there's a lot of her famous paintings that have been made into a cube. So that's an example of a square, right? And then right here, you've got this building that has been built in the form of the shape of a parallelogram. And then right here's a flag for Guatemala, I believe, and you can see the rectangles here that make up the Guatemalan flag. Another cool thing about quadrilaterals, though, is that they use them in all kinds of other areas, other kinds of subjects. So, obviously a carpenter had to construct the trapezoid, right? So someone had to design plans for that table. Architecture, to build the building that's shaped like a parallelogram. Of course, art. They use shapes in art, so quadrilaterals are heavily used in art. Even like geography, you got these flags that use quadrilaterals in their flags, and a lot of times, depending on the country, these shapes have specific meanings. I know that Israeli flag, that's the Star of David, which is a holy symbol for people that are of the Jewish faith that typically live in the country Israel. Okay, of course, aerodynamics for like a kite that flies. So quadrilaterals are just really used in all kinds of different areas. Okay, so let's look at some properties that you're actually going to need to remember in order to do the problems today. So first is parallel lines. We need to remember that parallel lines have the same slopes. So if the slope of one line is 1/3, then a parallel line to it must also have a slope of 1/3. Okay, they got to have the same slope in order to be parallel lines. All right, second is congruent sides. So in order to figure out sides that are congruent, you're going to need to remember how to find the distance between 2 points. Okay, so we've got to be able to figure out the slopes. We've got to be able to figure out distance. Remember, with distance, you can use distance formula, or an easier thing to do is just count and use Pythagorean theorem to find the distances of the sides. Okay, next is bisectors. So you've got to be able to figure out if lines cut each other in half. So in order to do that, you need to know the midpoints. Okay, so you need to be able to find a midpoint. So we've used the midpoint formula for that, x1 plus x2. It's an ugly plus, looks like a bunch of x's in there. x1 plus x2 over 2. and y1 plus y2 over 2 will give us the midpoint so that we can determine if we have bisectors or not. And then last, 90-degree angles. In order to determine if two lines make 90-degree angles, they must have opposite reciprocal slopes, which we've talked a lot about. And just to remind you what that would be, an example, if one slope is 2/5, then a line that has an opposite reciprocal slope must have the opposite sign, so it would have to be negative, and you have to flip the fraction to make it a reciprocal, 5/2. Okay, so those are some things that we're going to have to remember in order to do the problems today. All right, so there are the formulas up there that we'll need. Of course, you need rise over run to find slope, or you can do y2 minus y1 over x2 minus x1, and then the other formulas that I gave you. For distance, again, you don't have to use the whole distance formula. You can just use the Pythagorean theorem by counting on the coordinate plane. And then down here we've got some strategies, okay? So this is a lot. I understand this is a lot, but again, the ones that are highlighted on here are the ones that are the easiest way to do it, okay? Take the least work. So, you know, if you're someone, you know, for example, for proving a parallelogram, number 1 here says to check the slopes of each side, all right, and make sure that the opposite sides are parallel. So you've got to do slope formula 4 times, okay? So you could just do that one if you really like slope, okay? Number 2, check the distance of each of the opposite sides and make sure they're congruent. So you got to do distance formula 4 times, okay? So you could do that if you really like the distance formula. But the easiest one is to just figure out if the diagonals bisect each other. So all you got to do is do the diagonal midpoints, figure out the midpoints of the two diagonals, and see if it's the same midpoint, okay? So if you do the midpoint formula twice and get the same point with the diagonals, then you're good. You know it's a parallelogram, and that's probably the quickest way to do that one. Okay, proving a rectangle, you got to be the easiest way is to prove the diagonals are congruent. Just do the distance formula 2 times, right? But of course they can't be perpendicular, so you got to check and make sure that the lines are not perpendicular in order to be a rectangle. Okay, you could do this other one by proving there's a right angle. That means making sure that the two lines have opposite reciprocal slopes, and also you have to do one of the three things from a parallelogram to prove it's also a parallelogram, not just a quadrilateral that has one right angle. Okay, so also for a rhombus, you can just prove the diagonals are perpendicular. So all you got to do is the slope of 2 lines are opposite reciprocals. Okay, but you got to make sure they're not congruent. So you got to show the distances are different. Or you can do all 4 sides are congruent, but not 90 degrees. So you got to do distance formula 4 times and slope twice, which can be a lot. Okay, proving a square. Okay, you can prove one from a square and one from a rectangle. So just pick one thing from the, or not, I think I should say rhombus and one from a rectangle. So pick one thing from rhombus and one from rectangle. Let me mark that out. One from rhombus and one from rectangle. Or the quickest way is just to prove that the two diagonals are congruent by making sure that you're doing distance formula twice, and then making sure that the diagonals are perpendicular by figuring out their slopes and make sure they're opposite reciprocals. Okay, proving a trapezoid, these can take a while. You got to do slope 4 times to make sure that you only have 2 sides that are parallel. And then to prove an isosceles trapezoid, you have to do the same thing that you did for proving a trapezoid. Do the slope 4 times, make sure that 2 of the slopes are the same, and then you got to prove that 2 of the legs are congruent, so you got to do the distance formula twice. And then lastly, a kite, you got to check to make sure that none of the sides are parallel. So that requires you to find distance formula for all 4 sides, and then also find the distance of the 4 sides by doing distance formula, and make sure that you have 2 sides that are the same length that are side by side, and the other 2 sides are the same length that are side by side. Okay, then you know it's a kite. Okay, so I know that's a lot, so let's go ahead and practice doing one, and maybe make a little bit more sense. All right, so WXYZ is a quadrilateral with points W at 1, 5. So we're going to graph that 1, 2, 3, 4, 5. X at 5, 0. And then we've got Y at 0, negative 4. And Z is at negative 4, 1. Okay, so the question is, what's the most specific name for this quadrilateral, and how do you know? So this looks like it's a square just by looking at it. So if we want to determine if it's a square or not, the easiest way to do that is to look at the diagonals and see if they are the same amount, if they're congruent, and also if they are perpendicular to each other. So first, let's see if they're perpendicular, because all you got to do for that is figure out the slopes. So to find the slope, I'm going to count rise over run, right? So it looks like I rise -1, and I run 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so for the diagonal ZX, my slope is -1 over 9. The other diagonal is WY. So I need to figure out what's the slope of WY. Well, WY goes up 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1. Okay, so I go over 9 and up 1. So my rise is 9 over my run 1. So that gives me 9. Okay, so we want to know, are these opposite reciprocals? Looks like it. We've got -1 over 9 and +9 over 1. So yes, these are opposite reciprocals. So we can say they are perpendicular, but we also got to make sure that they're congruent to each other. So we need to figure out the distances. Okay, so to figure out the distances, you just need to use Pythagorean theorem. We counted 1 and 9. Don't worry about the signs right here. So you can use the signs, but you don't have to. So we can just say for the distance of ZX, we're going to say 1 squared plus 9 squared equals C squared, where C is the length of ZX. So 1 squared is 1, 9 squared is 81. So we get 82, and then take the square root. So C equals the square root of 82, which I believe is like 9.06. Okay, then we need to do the same thing for WY to ensure that it's the same length. Right, so WY is also 9 and 1. So we'd also do 1 squared plus 9 squared equals C squared. Well, obviously, those are the same exact numbers we used before, so that's still going to give us a square root of 82, which is going to be 9.06. So we see that they're perpendicular and they're also congruent. So because our diagonals are perpendicular and congruent, we can conclude that this is a square. So we might want to say a statement down here, square because diagonals congruent and perpendicular. I like to use a lot of symbols and abbreviation when I'm doing my statements, but you need to be explicit and make sure you write those statements out. Okay, let's do another one. All right, so similar, we got W at -3, 3, and X is 1, 5, and then Y is 4, -1, and Z is 1, -5. Okay, so when we connect these, okay, it looks like we've got a shape that resembles a trapezoid. Right? Looks like we've got two parallel lines. So we're going to have to figure out a way to prove that. WX, Y, and Z. Okay, so to prove that, we need to determine the slopes of these two lines. So let's figure out the slope of XY. It looks like this one is parallel to this one. We don't know, but let's check and see. So the slope of this, we go down 1, 2, 3, 4, 5, 6. So that's -6, and we go over 1, 2, 3. So the slope of XY is -6 over 3, which is -2. And the slope of WZ, we go down 1, 2, 3, 4, 5, 6, 7, 8. So that's -8, and then we go over 1, 2, 3, 4. So the slope of WZ is -8 over 4, which is also 2. Okay, so we've got, for sure, we've got one set of parallel lines, but in order to be a trapezoid, it can only have one set. It can't have two. So we need to check the slope of the other two sides and make sure they're not parallel also. So we count over and up. So our rise is 4, and our run is 3. Okay, so ZY is 4 over 3. And what's the slope of WX? We go up 2 and over 4. That reduces to 1/2. Okay, so that's good because these two are not parallel. So not parallel. And of course these are parallel. So we know we don't have a parallelogram, we've got a trapezoid, but is it an isosceles trapezoid or not? So to determine if it's isosceles, we need to know the distance of the two sides that are not parallel, because if they're the same distance, it's isosceles. If they're not, it's just a regular trapezoid. So what is the distance of WX? Well, we went up 2 and over 4. So the distance is 2 squared plus 4 squared equals c squared. And then the distance of ZY is 3 squared plus 4 squared equals c squared. Well, it's pretty obvious right off the bat, these aren't going to be equal because 2 squared plus 4 squared is not going to be as much as 3 squared plus 4 squared. So we can tell these are not congruent. So since those two sides are not congruent, this must be just a regular trapezoid. So we can say trapezoid because one pair of parallel sides and legs not congruent. Okay, so that's a good statement right there to state what shape it is and how we know that. All right. Okay, so I'm going to go ahead and pause the video, let you guys try this one, and then I'll go over it. So go ahead and pause it, give this one a try. Okay, so I graphed my 4 points and connect them, and my thought process looking at this is, hey, that looks like a kite. So in my mind, I'm trying to think which one of these shapes, which one of these quadrilaterals does that resemble? I think it looks like a kite. So I'm going to see if I can prove that it's a kite. So in being a good student that I am, I'm going to go back and look at my note sheet and see what does I need to prove it's a kite. I need to check to make sure no sides are parallel. All right, so I got to figure out the slope of all the sides, right? So I'm thinking, okay, well, if it's got to see if they're parallel. To determine if they're parallel, I need to know, well, what's their slope? Because if they're parallel, they should have the same slopes. So I got to make sure that all the slopes are different. And then it says find the distance of the 4 sides and compare the lengths. If 2 consecutive sides are congruent, then it's a kite. So I've got to figure out the lengths of the sides by doing the distance formula or Pythagorean theorem, because that's what I'm thinking is how I figure out the distance or the lengths of the sides. Okay, so first of all, let's figure out the slopes. So if I want to figure out the slope of WX, I'm going to count down and over, down 3, so it's -3, and over 2. So the slope for WX is -3 over 2. And then I'm going to figure out the slope for XY. So I say, all right, we'll go up 3 on Y and over 2, so it's +3 over 2. And then the slope for ZY, I go down over, so I go down 3, that's -3, and over 1, 2, 3, 4, 5, 6, 7. So I'm going to go down 3 and over 7 for ZY. So it's -3 over 7, because I'm thinking in my head, it's rise over run. I rise -3 and I run 7. So it's got to be rise over run, -3 over 7. All right, and the last one, ZW. Start from Z and rise 3 and run 1, 2, 3, 4, 5, 6, 7. So I rise 3 and run 7. So again, I'm thinking rise over run, +3 over 7. Okay, so now again, we want these to all be different. None of them can be parallel. So are any of these parallel? So what I'm going to check for is WX parallel to any of the others. Well, is WX got the same slope as anything else? Nope. Okay, so that's good. Does XY have the same slope as anything else? 3 over 2? Nope. And then is ZY the same as the one that's left? Nope. Okay, so I'm good. So all of them are different. So far, so good. I've got to now check the distances on each side and make sure that I have 2 sides, 2 consecutive sides that are congruent. So I'm going to take these same numbers and plug them into Pythagorean theorem. So for WX, I'm going to take 3 and 7, or sorry, for WX, I'm going to take 3 and 2. So say 3 squared plus 2 squared equals c squared. 3 squared is 9, and 2 squared is 4. That's 13. So I get the square root of 13 for C. All right, square root of 13. Now I'm going to do the same thing for xy. So xy, I also use 3 and 2. So obviously, I'm going to get the square root of 13 for xy. So now I know this and this are congruent. Cool. All right, now I'll check this distances on the others. Negative 3 and 7. So that's going to be 3 squared plus 7 squared equals 2 squared, which is 9 plus 49. That's going to give me 58. So the distance of zy is the square root of 58. And then I do the same thing for zw, but I'm using 3 and 7 in this situation. So again, it's going to be the same thing. It's going to give me the square root of 58 because I'm still using 3 and 7. So that means that zy and zw are congruent. Okay, so now I've proven that it's a kite because it has 2 pairs of consecutive sides that are congruent. Okay, right here's a pair of consecutive sides, zw and zy, and then the other pair of consecutive sides, wx and wy, congruent, and also show they're not parallel. So I can say it's a kite because no lines parallel and 2 pairs of consecutive sides congruent. All right, so that's all I'm going to do for that. Okay, something real quick that doesn't take long at all. Okay, so given that ABCD is a parallelogram, find the missing vertex point D. So this isn't classifying. This is a little bit different. We're given a shape, and we want to find what's the missing point. Okay, so you don't have to have a graph to do this. It's a little bit more helpful sometimes, but that's all right. Let's just pretend we've got a coordinate plane here. Maybe we'll pretend we got a coordinate plane here. There we go. Strange. We are slaves to technology, I guess. All right, so given ABCD is a parallelogram, find the missing vertex point D. So the whole point is to figure out what are the coordinates of D. So let's pretend we've got a graph here, and we're going to go ahead and put the points 2, 3, somewhere around here. B would be 8, 1, which is going to be somewhere out here this direction. 11, 5 is going to be even further out, but a little bit higher. And then X, Y, so we're assuming it's going to be somewhere in this general region if it's a parallelogram, right? You have to be up here somewhere in order to make it a parallelogram because the sides should all be parallel. Okay, so knowing this, this dot right here is A, so that's 2, 3. And then right here we have B, which is 8, 1. Up here is C, which is 11, 5. And we want to figure out what is D. Okay, that's the whole question. What is D? So essentially all you need to do is figure out, since it's parallel, the slope should be the same. So however I change to go from B to C, I should change the same way to go from A to D. So what did I do to go from 8 to 11? I added 3. So I'm just going to add 3 to the x-coordinate for A. 2 plus 3 is 5. Okay, so just do the same thing. And then the same thing for your y-coordinate. What did I do to go from 1 to 5? I added 4. So I go from 3, I add 4, 3 plus 4 is 7. So D must be the point 5, 7. All right, so I'm going to go ahead and pause it and let you guys try the next one. All right, so right here we've got these 3 points, and we want to find point S, which is up here towards the top. So we graph the points as close as we can to where we think they would be, and then look and see what happened to go from Q to P. So from the x-coordinate to go to Q to P, we subtracted 3. So we subtract 3 from the x-coordinate on R, and that gives us 0 for S. Do the same thing for the y-coordinate, -2. To get to 4, we add 6. So then we take 3, which is the y-coordinate for R, and add 6, and that gives us the y-coordinate for S, which is 9. I appreciate your all's time today. Go ahead and start your paper practice or IXL.